Have you ever thought why STAAD sometimes shows steel percentage in RCC column below 0.8%? Even though IS 456 recommend it as minimum? See, this is a common query among students and today I am here to decode it for you with a practical example. Stick around and we are deep diving into these essential concepts. Welcome back to Civil Nirman, where we turn technical queries into practical insights. So it's all about understanding why STAAD sometimes design columns with steel percentage below the 0.8% minimum specified in IS 456. Now to make this clear, I'll explain the relevant clauses from the code, STAAD's approach, an example that bridges the theory and practical consideration. So let's first understand this particular clause in IS 456. See, as per IS 456, a column requires a minimum of 0.8% steel reinforcement based on the gross cross-sectional area. But there is an exception to this rule and it is mentioned in the code as well. And the exception states that for the column with larger cross-sectional areas than the required to resist the direct stress, the steel percentage can be calculated based on the required area of the concrete and not on the actual area. So this is where STAAD's design calculations align with IS 456. Now let's understand how STAAD interprets and designs the column. See, STAAD uses advanced algorithms to calculate the required cross-sectional area for a given column based on the applied loads and design parameters. So if your column is over-designed in size, meaning its actual area exceeds what is needed for the strength, the minimum steel percentage is recalculated based on the required area and not based on the actual dimensions. So you might have a question why steel percentage may fall below 0.8%. See, this adjustment explains why you might see reinforcement percentage below 0.8%. For example, if the gross cross-sectional area of the column is large and the required area of concrete is much smaller, the actual steel reinforcement will be proportionally lower. So let's understand this particular through an example. Let's say you have a column with a gross cross-sectional area of 500 by 500 mm. The applied load and design calculation shows that only 300 by 300 mm area is needed to resist the direct stress. So in this case, the steel percentage will be based on the smaller required area and not on the gross section area. So if STAAD designs the reinforcement based on this required area, the percentage can indeed fall below 0.8% of the gross area but still satisfy the code. This feature ensures the material optimization without compromising safety or code compliance. So STAAD considers the exceptions in IS 456 to produce the designs that are both efficient and accurate. So the next time when you notice steel percentage below 0.8% in your STAAD design, don't be alarmed. See, remember the exception clause in IS 456 and consider whether your column's cross-sectional area is larger than required. It's all about understanding the code and trusting the software to optimize your design. If you found this explanation helpful, hit the like button and subscribe for more structural engineering insights. If you have more queries, drop in the comment box. And always remember, don't just learn software, learn concepts. Thank you.